Hi, this is Dan Doherty with the Balmoral Group, serving as chairperson for the Florida Water Resources Monitoring Council, and we're bringing you a webinar from the Southwest Florida Water Management District. So thank you to their team, and stay tuned.
Okay, good afternoon. Welcome everyone to this Florida Water Resources Monitoring Council webinar. This one is brought to us by the Southwest Florida Water Management District. So a big thank you to them, to SWFWMD, specifically to Catherine Walden and some of her team who will be presenting for us today. So, I mean, a big goal of the Water Council is just to improve how we're learning from each other. And so the goal here is today is SWFWMD is going to share some of their lessons learned and how they put together and implemented their environmental data portal. So I'm going to turn it over to Catherine Walden. Before I do that, if you near the top of your screen, you'll see like a line going across horizontally across your screen. If you can drag that up or down to make the little people's initials go away, if you'd like, and make the screen bigger. Please do mute your microphone if you're not talking. That'll help us be able to hear everyone better. At the top right of your screen, you'll see a little chat balloon. So if you click on that, you can put questions in there. So we really do want this to be as interactive and discussion focused as possible. So please do ask questions at any time, either through the chat or directly, unmute yourself and ask whatever you want to ask. It's really no interruption at all. That's what we're looking for, is to for us to all get our questions answered here. So feel free to use the chat or just ask away. With that, thanks everyone for joining us, and go ahead, Catherine.
Great, yes, thank you, Dan. I did want to say thank you for the team as well. Thank you to you as well as the folks at FDP who helped to organize the Florida Water Resources Monitoring Council and give us this opportunity to, like you say, kind of share our knowledge and learn from each other as well. We are hoping, as you mentioned, to have some really good discussion. And this presentation is about our implementation, and as I'm sure most of you know, if you've worked on an implementation of a software prior to this, that the implementation is ongoing. So we're always learning. We're always looking for input from others, and your question may spark something, an idea or something that really helps someone else. So please don't feel like you're interrupting us. We called this a roundtable for a reason. We wanted to give different perspectives, and we want to hear from you as well if you have questions and comments. So, Dan, as he mentioned, is going to monitor the chat. So if you don't feel comfortable, you can go ahead and type your question into there, and he'll speak up and give those to us. We're hoping to do about 30 to 45 minutes talking about our implementation, and if there's time, it kind of depends on how brisk the conversation is, but if there's time, we would also like to give you a brief demonstration of the system, the public-facing portion of our system, which we call the Environmental Data Portal. So kind of how we're going to start out here is we're going to start out with Granville and myself, and I'll change slides here real quick. Granville and myself, we're going to kind of talk about the actual, how we started the process of implementing a new database. So kind of from that, budgeting, figuring out requirements, those kinds of things. We're going to talk about that part first. Then we're going to pass it over to some of our subject matter experts in the different areas of hydrologic data, as well as water quality data. It's going to be who also works in our hydrologic data section and is a subject matter expert and kind of some of the high level tips and techniques for anybody really implementing a large project like a database implementation. So hopefully you also got the email showed you or that gave you the link to the portal, and you've had a chance to check that out. I just like and some of you may have looked at our old system as well, so you can maybe know the difference between the two. So with that, like we said, please let us know any questions, comments as we go. And I am going to Granville to start discuss the next topic.
Good afternoon, everyone. Hopefully, we're not going to have any audio problems. I'm just having some audio problems just now. But as Catherine said, I'm the manager of the hydrologic data section, and what I just want to do real briefly is just set the stage for where we started and where we needed to go. The Water Management Information System was our corporate database. It was in place, I think, probably early 2000s, and it's made up of two major components: the resource data, which is our area, and then the e-permitting. And the whole system is being replaced separately, but what we needed to do was replace the resource data side. This resource data side contains scientific data, hydrologic data like groundwater levels, surface water levels, surface water flow, atmospheric data like rainfall and evapotranspiration, and also groundwater and surface water quality data. So that's the source of all of our important data that we use for all our work we do, from flood protection to permitting to reporting. This system, because it was custom built around our district processes, worked very well for us for the time that we had. As I said, it was integrated with our e-permitting system, so that we had some commonalities that we were able to capture, and it worked well for us while we had it. Some of the cons that we had with it was that the data structure that it was built on was very complicated, which made queries, and you had to query data against the databases, complicated because different data were in many different tables. So you would have to do joins. You have to have a real good understanding of the database. And we also had some challenges of getting all of our data in there from our various sources. It was very expensive to build and to maintain. We ended up having a total investment of around $20 million, and it was never really fully built out to do some of the things that we really wanted to do, because we reached a point where it was so expensive that our governing board really sort of pulled the plug on further development. Catherine, if you want to move to the next one. So in about 2017, we started talking, actually probably a little bit earlier than that, about the need for next generation. And Catherine will actually talk about the procurement for that. But we really needed to do this because the technologies that this was built on were nearing the end of life. And there were a lot of components. This was built by a contractor for us. And some of the various components were no longer going to be supported. We also had a significant loss of staff knowledge. The people that built the system, the contractors were long gone, and it was taken over by district staff. In 2011, we had a reduction of force, and we lost a number of people. And the remaining staff had to keep this running, and as time went on, we've had retirement. So the people that were most knowledgeable about this old system were retiring or have retired. The next thing is the Oracle database structure are being planned to be replaced. We've been talking about that for probably about 15 years. Oracle is very expensive, and all the various Oracle components are on a planned obsolescence cycle. Basically, we're trying to get rid of them and replace them with other things that are cheaper for us. And then finally, there are so many newer technologies that can fill in the gaps and provide, for example, graphing or mapping that we were lacking in the solar system because we didn't have the technology when it was built. Catherine, you want to go to the next one? Really the goal of this whole process was to simplify things and to add functionality and to provide these modern technologies that we talked about. This shows you where we were with our WISKI system, and I'll walk through this very briefly for you. This Kister's Hydro is a software that we use, and some of you use now, that we used for data editing, data quality control, and basically all of our data on the hydrologic cycle from whatever sources came into the system and then had to go through a series of hydrologic data pumps, or you can call them data loaders, or extract, transform, load processes in order to get into the WISKI database. The water quality was even more complicated because there were some data that were going into Hydra and would come through our data pumps to go in, but there were a number of other sources that had to go into a separate data pump, data loader to go in. And then, of course, there were some ecological data that were being loaded directly. So we had a lot of very complicated ways of getting data into the system. So really, that's where we started. And Catherine, if you want to go, and you can start talking about how we actually proceeded on this.
So as Grandma really kind of got involved in this implementation around 2017, but we had actually kind of started the discussions. I think some of the stuff, when I go back and look, we started talking about budgeting and kind of gearing up, so we knew how we were going to proceed around 2014, 2015, and that was about, we were looking at around getting to close to 10 years with having WISKI. So we had quite a bit of time with the older system, and we had some ideas about the things that we knew that we wanted with the new system. And one of them was that we wanted it to be an off-the-shelf, customizable off-the-shelf system. So we wanted it to be something where we would have support from the vendor that was providing it to us throughout the life of the program, unlike WISKI, where it was built and then over time, a lot of the support and maintenance of the system actually fell on our IT and our staff at the district. We wanted to evaluate alternatives. There were some major players that we were looking at, including Hydra, which we were already utilizing, the successor, I guess you would say, of Hydra, which is WISKI, and as well as Aquarius. We did some reaching out, requested presentations, and we discussed about the pros and cons of all of those systems. And in addition to the pros and cons of the systems, there were also cost considerations that went into that. And part of evaluating all alternatives is also that you have to navigate your procurement rules, and that there are certain requirements that we had to go through of the way that we evaluated the proposals that we had for the systems. So we ended up obviously determining that WISKI was going to be the system, so Kister's WISKI was the system that really met the most of our needs. And it provided a lot of the functions needed, including having water quality and environmental modules on top of having the hydrologic data modules, which Hydra, you're already using in Hydra. And WISKI was also the same parent company as the Hydra system that we were already using for our hydrologic data. So it made our implementation a little smoother, and it actually provided a lower cost alternative to upgrade from one Kister's product to another. So that weighed pretty heavily also in our evaluation and determination. You know, our overarching goal, I think that Granville already mentioned, was we wanted to simplify the processes, add functionality, and provide modern technologies. And we felt like, you know, something off the shelf, but still customizable was the way that we wanted to go. So for the procurement, as I said, we started talking about budgeting back in 2014. And we actually have a process at our water management district where we have a governance process that allows us to evaluate both IT and data related projects and initiatives in a way that gets executive buy-in and that makes sure that we're looking at all of the costs, the risks, the assumptions that we have to make. So we have a pretty robust governance process, and this modernization of our system actually went through that process in the 2017 time range that Granville was talking about. In addition to going through our governance, it also had to, you know, we had to get commitment from our governing board. So there was a presentation to our governing board and to obtain funding. And then we went through the process with our procurement to actually enter into an agreement, a contractual agreement with Kister's. So let's go to the next slide really quickly. So this is actually the after. So Granville showed or talked about the before processes, where there were a number of different data pumps that were necessary to get the data from both hydrologic data and water quality data into our systems, into WIMIS. And there was a lot, and as the system aged, there was a lot of extra effort that had to be put into actually getting those data pumps to work and making sure that our data would actually make it into WIMIS. With the upgrade to Kister's, we simplified, I don't have the numbers, but we simplified the number of data pumps significantly, what we went down from 2, but it was significant. We also were able to interface with our GIS database, and we have as we mentioned, there's the environmental data portals that provide our data both internally and externally to our customers, and we have the actual WISKI and Kister's product that our hydrologic and water quality data staff work in. So we saw, again, simplification and elimination of complicated processes. We definitely had new tools. Oh, yes. Go ahead.
Hey, this is Dan. I just wanted to ask a question that came through in the chat. Can you say a little more detail about what a data pump is exactly?
Yeah, so a data pump is kind of it's generally, or my experience is, it's usually some type of scripting or some other tool that you have to have intermittently between your data and your ultimate database. So so some of the data pumps we had that some people may be familiar with on the water quality side was we were using ADAPT and EDMS, or not, EDMS? Yeah, EDMS. Sorry, it's been a while. To actually, we would take our data, put it in ADAPT EDMS databases, which were access databases, and then we'd have to actually push them from there. So we'd have to get it into the ADAPT system and whatever format that needed it. Then we'd have to get it into WMIS and always another format. So ADAPT EDMS is an example of a data pump. Sometimes it's scripting, additional scripting that's necessary to take data from one source and move it to another destination. I think that's probably how I would describe it, the data pump. Does anybody else have any on the table? Does anybody have any other comments or thoughts on it? Basically, data pumps are they're the Band-Aids. Not always. I mean, you do have to pump data, from your source to your ultimate database. But if you have multiple data pumps for different sources, rather than having just one flow through, you can start adding a lot of Band-Aids as you go to it can become kind of like a crutch to continue to use an outdated system. You're using data pumps to kind of get to the end result.
Catherine, just to follow up, it's essentially an extract, transform, load process. You're extracting data from one data source, you're transforming it, and so that it can be received by another data source. So, and this loaded. So it's basically just taking data from one data source and making it fit into another.
And it sounds like, this is Dan again, sorry, it sounds like that sometimes involves some staff intervention to actually run it. It's not fully automated in some cases. It would have to be someone running a script or someone, moving data from one place to another. Is that right?
This is Mark. Oh, sorry. This is Margaret. I was just gonna say a lot of these were set up by our Oracle DBAs. Because basically, they had these scheduled. These are jobs that were scheduled, and that they would download data, run a query, download data, transform it, maybe using some other software, and then there'd be other scheduled jobs that would import those data in the new format into another system. So you're basically just usually extracting data from one system, transforming it, and then loading it to another, as Granville said, like an ETL process. And we just called them data pumps, but that seemed to be the standard terminology, but I'm sure you could, other people probably call them other things, but it's just a process that runs in the background to move your data between systems.
One of the problems was because these were built by our ITB staff, if anything went wrong, we would have to involve them to fix it too. So it was a big overhead that we had.
Yeah, it added places where things can break, for sure. Added complexity, for sure. Is there another question? Oh, I see, I understand. Okay. Okay, so I think I've kind of covered this. There were many benefits and efficiencies that we got from implementing and upgrading into WISKI. And so now we're going to kind of switch gears a little bit and talk about the actual implementation itself. And we're gonna start out with Asmita Shukla, who is in our hydrologic data section, and she's a lead data analyst, and she will be kind of talking about, from the hydrologic data standpoint, some of the things that she learned during the implementation, or we all learned during the implementation. So go ahead, Asmita.
Hi, everyone.
Hi.
Can you hear me?
Yes.
Okay. Hi, I'm Asmita Shukla. I am a lead hydrologic data analyst with the Southwest Florida Water Management District. And I was just going to talk about unrealistic expectations when you move to an off-the-shelf software. People have a lot of these unrealistic expectations when they think about off-the-shelf databases. And I just wanted to talk about some of those which we had and what actually is a realistic scenario. So the first one I wanted to talk about was that people think that data can be migrated without a considerable format change. Now, when we moved from Hydra to WISKI, the parent company was the same. So when we started this project, especially me, I thought, oh, I could just take the files from Hydra and just, export them using standard applications, which Hydra comes with, and then load to WISKI. But that was not the case. I had to write a lot of custom scripts to format the data, which was coming from Hydra, so that it could be loaded to WISKI. So this is something you should always keep in mind when you're transitioning from a customized database to an off-the-shelf system. The second would be that, you would think that the vendor would understand all your data organization needs, but that is not always the case because no one knows your needs better than yourself. So just for example, when we went from Hydra to WISKI, we wanted to organize all our data based on monitoring frequency and collecting organization. As a district, we also get a lot of data from other external organizations, so we wanted to categorize our data like that. But initially, the vendor suggested that the best way to store our data would be everything in one time series. But that wouldn't work for our purposes because we only use district data for our analysis. So we wanted to keep it separate from other external agency data. So that was one thing that we learned, that you have to explain when you're transitioning that how you're going to use the data so the vendor understands. And another one would be that you would think that you won't have any system issues or the software bugs, but most companies have extensive testing for softwares, but a lot of times, since these databases have improved over time, they've been developed over time, they have so many applications, so many functionalities that it is unrealistic to be able to check everything when a new version comes out. So you should expect software bugs. So every time you have a version update, it's going to take considerable time for you to go and check the functionalities you're using. And then do not expect that you will get everything from your old system plus some more. There's a balance. It really depends on what you're willing to lose versus what is there to gain. You have to lose some functionalities to gain some others. For example, when we moved from Hydra to WISKI, we lost the process where we used to change the quality codes in a batch job. For example, all our data used to come in as unchecked, then it went through the QA/QC process, and then we changed the data from unchecked to good quality, or flagged it however it was needed. But when we moved to WISKI, that functionality went away. There was no way for us to have a batch job which would do this change for us. So then we had to modify our process. So now all our data comes in as good quality. We conduct our QA/QC processes on a daily basis. So when the data goes out to the portal, we're making sure that it is all good quality. So this is one functionality we lost, but we also gained the web API services, which were great for programming and for transferring data to external users. So there's a balance. You shouldn't expect to gain only. You have to lose some of the things you have. And then always keep in mind that the total time for a successful migration is development plus production. Most people think that you're just going to have one server move everything and then it's going to run smoothly, but that doesn't happen. You have to do the database migration in development, then you set up your ETL processes in development, then you migrate to production, and then set up your ETL processes in production. And this transition from development to production is not necessarily always smooth because these are two different servers we are talking about. So always keep in mind that the time you're going to take is development plus production. And if you have an acceptance environment, then you have to add more time to it. And the last one I want to talk about is that an off-the-shelf system does not translate to no changes in future. Very frequently, the vendor decommissions a lot of functionalities. And in the last 2 years, I have seen it happen twice with the web API services. So if you're using those functionalities in your programs or in your ETL processes, be ready to figure out a workaround or be ready to change those processes based on the new functionalities the vendor is giving you. So you might think that when an off-the-shelf software comes to you, there will be no major changes, but once in a year, I would say there are always major changes you would need to make to your ETL processes. So I just wanted to touch base on these unrealistic expectations and what you should actually expect. So basically just plan ahead and give yourself ample time for this transition. That's all I had to say. Thank you. And if you have any questions, I'll be happy to take them.
That's super helpful. Thank you, Asmita. I have one quick question
Sure.
before anyone else does. So you mentioned you expected, like probably anyone else would, that moving from one Kister system to another, there would be some like import export functionality. Those systems could talk to each other.
Yes.
Did you know ahead of time if that didn't work, that it would be like your job to fix it, or the district's job to fix it? I mean, I would have assumed that would have been like a vendor issue, that they would have to fix it, but it sounded like that you all like wrote some code to resolve that. Is that, did you know that was plan B?
Yes, there is actually a Hydra application which we use to export the data from Hydra in XML format, and that format was supposed to be WISKI ready, but since the way we wanted to organize in our data in WISKI was very different from what that default application creates, that is why we had to do some custom scripting. So when these companies write these applications, they are taking data from one system to the other thinking this is the format everyone would want, but that is not true in every case. We reorganized our data, so that is why we had to do a lot of custom scripting. Does that answer your question?
Yeah, okay, got it. That's helpful. Thanks.
Sure.
If I could just make a comment, it's really helpful to have very smart, talented people in your group when you do something like this. And we benefited from that. What we found was that if we had relied on the contractor to do all this reformatting and everything for us, we would have probably added a year's worth of time, literally. And we would have had to hold their hand the whole way through, because they did not come in with any strong understanding of the way our data were structured or how we use them. And of course, we had a very strong understanding of both of those. So the combination of talent plus the knowledge really sort of pushed us in the direction of what Asmita was just talking about, us actually taking a leading role in this.
Thank you, Anita and Granville as well. So now we're going to turn it over to Trevor, unless there's other questions. Sorry.
Hey everybody, my name is Trevor Fagan. I'm an environmental data project manager, and I'm in the water quality monitoring program with SWFWMD. So I do a lot of the water quality data review and loading, and I'll talk some about the water quality perspective. And I apologize ahead of time; it's going to be a little bit duplicative in terms of some of the things that the folks in the hydro group have brought up. So I'll dive right into it now. So there's definitely some challenges associated with assimilating our continuous water quality data into the system. So one thing for us, and when I say us, I apologize, I mean the water quality monitoring group, we've historically been on the collection side in terms of discrete monitoring. So what that is we're collecting readings periodically at different stations. In the last few years, I'd say the last 5 years, we've sort of gotten into collecting near real-time data at continuous water quality stations. When we started that up, we were still using the WISKI system that Kat and Granville had mentioned previously, and that web-based system was never configured to represent our water quality data in near real-time fashion externally. So in transitioning to WISKI and QUICM is the water quality module, it's Kister's water quality module, we were presented with the opportunity to now be able to represent this near real-time water quality data externally. So this was sort of like a new endeavor for our group. to represent those readings externally. So it was phenomenal for us, because the Oracle systems that Catherine was mentioning earlier are how we were having to give data to folks previously. So those were all sort of behind the scenes grabs in Oracle database to give to anybody who wanted to consume that data. So that was really big for us. And one of the high level sort of relationship things within this database are both near real time or continuous or time series data, equidistant, if you will. So that's going to cover both hydrologic and water quality data in the system, and discrete data. That's going to be a separate data set in a separate module. If you find yourself using what we call the client, that's going to be the different things like WISKI, QUICM, CAICA, which is the ecological module. Sorry. Those are different things within the software itself, what's externally represented through the portal. It'll all be within that particular environment or application, if you will. But there'll be a little bit different navigating. So by default, if you go into our portal, the hydrologic data is represented in there, and that's going to cover our continuous water quality data. If you want to see discrete water quality data, there's a separate label that you can select that says water quality, and that'll show you the discrete data. That's sort of like high level, not so high level all at the same time. I apologize about that. So something that was super beneficial to us in terms of the success of this migration was having a liaison within the IT department that sort of understood the data that we're collecting and reporting, and making that data understandable to the contractor. And we have been super fortunate to have several different folks within the IT department that totally understand the information that we're collecting, which most of the folks on this call can totally understand that it can get sort of confusing because we're very particular about our data. And it was so helpful to have folks that were also very particular about our data and can also make that understandable to the folks that are going to be configuring the enterprise database that you're migrating to. That was very helpful. So another thing that we faced was sort of, I guess it's a comfortability thing with the WMS system that we had. There were definitely certain facets of that that database that we thought were sort of industry standards, if you will, that did not necessarily translate into the migration. And there was a learning curve for that with us, for sure. One of the things was a different level of relationship in how just the data lived within the system, sampling, parameter, project, all those sort of things had to be learned, because that was not a part of the database that the water quality group was always involved with. But there's definitely benefits to that in terms of like anybody that loads data to Storette, when some of those FDEP databases, it opened up an opportunity for us to start storing things sort of at parameter levels and measuring program levels. And what that would let us do is take things that we had historically added sort of at that result level and make those sort of things that I guess, quote unquote, we could put within the data pump itself. And there are processes that operate behind the scenes, like ETL processes, where when we generate a report within WISKI or QUICM that takes something that we would generally, like, say, an analysis method for pH, dissolved oxygen, something like that, where that's something that historically may or may not, for different agencies, been at that result level. We could assign that into WISKI QUICM and have that go externally in our WIN report to go to the WIN FDEP database, which was definitely beneficial, but it's also something where it used to be an IT component, and now it's something that the folks in the water quality group are maintaining. So there's like a balance, I think was mentioned in some earlier discussions. So that's something we've also learned. And we touched on this with the hydrologic data, the data conversion and configuration. It's saying that's a very time-intensive process is an understatement, to say the least. It's something in the water quality group we're still ongoing. I am continually doing updates to that, and we have the folks not just within our organization but externally that have pulled the data in the EDP or even viewed it, and we've learned sort of like leaving data how we've historically collected with the historical nomenclature can extremely clutter how it's represented in the portal. So definitely one thing to consider is modifying that as you're doing your what we call historical migration load. And that's basically just taking the data that was in your old system, putting it in your new system. And what cannot also be understated is over communicate your expectations to not just the users of the system, but also the folks that you're purchasing the system from and that are helping you configure it. The folks that we've done this with have been extremely accommodating. And I say that because I still have weekly meetings with them on things that we're both undergoing and changing, and the changes that they're also representing have impacts within the system of the things we're doing. So test it again, test it some more, and you'll learn something every time. Redundancy is definitely out the window with this. Some of the other things we've learned are with that relationship that I mentioned earlier in terms of the parent-child. There's definitely been some negative impacts to how the water quality, more discrete data is collected and reported in terms of how we represent it. And because the system, WISKI, was configured sort of with equidistant data in mind, those relationships were built such that there was, for different things, there's only one data type that the system can accept. So sort of how water quality data has always been collected is if you collect depth profiles, those are done historically in meters. Because we also collect and report water level elevation data, the system was configured such that water data is collected and reported in feet. So we had to also associate an extra field, if you will, with our data that has our water quality results associated with both water quality data in meters and in feet, so the system itself can accept it, as well as things like daylight savings time. We've always collected and reported in local standard time. So if daylight saving times occur, we report the data in that in terms of discrete data. We can't do that because of the hydrologic data, because then if we also honored that, if we honored daylight savings time, then the hydrologic data is going to lose an hour and duplicate an hour twice a year, or sorry, one time a year. I apologize. So that definitely understanding things like that and compensating for that is important. Understand your data. I can't stress that enough. And as I mentioned earlier, like taking the ownership of your data. I didn't have an IT background, so I've sort of jumped in with the sharks and swam. And if this is something your agency, municipality, whatever level you're at are considering, go ahead and start understanding relational databases. Any sort of programming you can take, start learning it. It will immensely benefit you. And that's really all I've got to add to it at this time. Thanks everybody for your time.
Great. Thank you, Trevor. Does anybody have any questions for Trevor before we move on to Margaret? Okay, I don't see anything, so we're going to move on to Margaret. And Margaret's going to, like I said before, kind of talk some high-level keys to success. So go ahead, Margaret, take it away.
Thanks. Hi, I'm Margaret Kroll. I'm the Chief Scientific Data Analyst in the Hydrologic Data section. I just had some, I guess, summary comments really about the whole project. And these are, you know, nothing in the weeds. These are, I think, applicable to any kind of IT project or migration. In some ways, we were very fortunate that we already had a system in place, the WIMS system, and before that, we had another system in place. So we weren't starting from scratch, and I think I realized that through the process that when you already know what you have and you know kind of what you want, it's a lot easier, because otherwise you really are up to the mercy of somebody else to design your system for you. So my first word of advice, I guess you could call it, is that you yourself would have a thorough knowledge of your data and your processes at the outset of the project, so that you get what you want to get that's going to meet your organization's needs, and you don't just get something that's delivered to you. It may be better than nothing if you were starting with nothing, but really having a thorough knowledge and understanding about your processes and how things need to work was critical. We were fortunate to have a great great project manager at the district to handle this. She was the liaison between all of the groups that were involved, as well as with the vendor, and we had really good systems admin support also. So if you think you don't need a systems administrator, you'd be mistaken. You really need somebody who knows how the system's going to be set up on the servers and is able to work with you on that. And he was an integral, and still is integral, part of our team. On a higher level, you definitely want to get your executive and senior level staff in your corner, that they're going to support this and buy into the system and really be committed to seeing it through. I could also say that accurate project scoping is really important. This kind of goes with knowing your data and processes from the outset. I would file this under unrealistic expectations, as Smita mentioned earlier. Maybe not so much on our side, but we felt, I think, at some point that I think that maybe our vendor was surprised at really how complex our system was, how much data we had, how many monitoring stations we had. This, I think, if I'm not mistaken, ours is the largest implementation in terms of monitoring stations. So, and we have a lot of metadata, and which makes our system great and very useful, but it also presented a challenge to the vendor. I don't think they were expecting that. So you definitely have to communicate that and document it and have them really come and sit down with you and spend maybe a few days observing your processes, understanding what you're doing, what your data look like, how your users use the data. I think that would be a great investment in time at the beginning of the project, rather than suffering from scope creep later in the project, where you assumed they were going to provide A, B, and C, but they really didn't understand that you needed all of that. We also had really excellent and frequent communications among our team members in IT and hydrologic data and water quality. We communicated, we met on a regular basis. We used an agile approach to project management, and our district communications group, like our public communications group, they really kept our internal and external users up to date on a regular basis in terms of our system development. you know, when they're going to see the new system, what they need to expect, when we're going to be migrating, when there might be a system outage, that sort of thing. So we were fortunate to have someone in our communications section also invested in this project who could keep the users educated and informed as to our progress. And finally, just to say, this is like an ongoing team effort. This isn't something that's ever really going to be over. The migration may be over, but we're using the system and we're continually making improvements and extending it. There were some things that we just could not get from an external vendor. So there have been a lot of improvements made to the system, a lot of configuration changes. And again, we're able to customize it to our own needs. And there's been a lot of scripting done, apps, things that extend the power of the data portal. So it really helps to have staff that has an in-depth knowledge of the software and some scripting capabilities, and really the desire to continuously improve the system and the ability to develop these tools to expand the system, and understanding how you can integrate it into other systems you may already have at your organization, like a GIS system. We were able to, you know, kind of create additional tools and really make this is super helpful and useful for our organization. We offer a lot of workshops still. We provide ongoing support and training to our users. We have we've had quite a few workshops to individual sections within our organization to train them on using the system and answer their questions about using the data. So it's never really done. It's going to be an ongoing thing, and hopefully we'll continue to expand it and really meet the needs of our data users, and continue to develop tools and documentation that helps them use the system. But I think we've all learned a lot throughout this process, and I think it's evolved into something that we're all very proud of. So I'll be happy to answer any questions. I think we're running a little short on time, but if we do have time and somebody would like to see a demonstration of the system, we can do that also. It's just up to the group, I guess. Thank you.
Yeah, it looks like we only have about 6 minutes left. So if we want to forego any questions, if all the questions have been asked, we can do a quick demo, or if there are questions, we can answer them now. Maybe we can schedule something else for a demo as well. But.
Hey, Catherine, this is Granville. I'd just like to make 3 comments.
Yeah.
First one is kind of going to something that Trevor said. We migrated 1.5 billion records from our old system over into our new system. And so that gave us an opportunity to do a really deep cleanse of some of those data. If you know, after years and years of record, some things get out of whack, some things you miss, and sometimes metadata doesn't keep up with it. So both the water quality and the hydrologic data sites were able to do a deep cleanse of their data. The second point is really there are some unintended consequences of this, and the first one you heard throughout here is limitations of the off-the-shelf software. And the point I want to make is that what Margaret referenced, it was our staff, not the contractor, that was able to overcome the limitations of the software and develop some R code and Shiny apps to provide the functionality. Some just to keep the same functionality we had in our WIMA system, but also many to extend it beyond my wildest expectations going into this project. And then the other unintended consequence really was a fundamental change, because with this migration, our ITB, our Information Resources Group, has taken a smaller role in this software, and we have assumed a larger role, which has good sides and bad sides, but it's just something to keep in mind if you do this. This what happened within our organization.
Thank you, Graham.
Hey, Catherine, this is Dan Doherty. I know we just have 4 minutes left, but I would love to see just even like a couple-minute demo, just sort of for the record, so people can see how to get there and just to look around for a minute. I think would help people get started. So if you all are okay with it, we can go a couple minutes over 2 p.m. if we need to, so people can drop off as needed.
Okay, yeah, I think we're good with that. You'll just have to share with Margaret.
Okay, we'll do.
Yeah, and then I've already got my. Okay. Oh, perfect.
While you're pulling up, Margaret, I was going to say something that Granville said to hit off too. With this implementation, I think we also made ourselves probably a lot more secure, not just from the health of our data through cleansing it, but probably from using an off-the-shelf software. There probably may have made ourselves a little more secure from the IT risk standpoint too. Though there was quite a bit of finagling of that as well to put this system out so that people could access it and still allow us to be secure. So say that.
Okay, can everybody see my screen, which shows the main page of our external website?
Yes.
Okay, great. So this is what you'll see when you go to watermatters.org or SWFMUD State FLUS, our main page, and not surprisingly, you will just go here to the Data and Maps icon, and then the EDP, I'll call it the EDP, but the Environmental Data Portal has its own page here. And what you're going to see on this page is, in addition to a link to the EDP, there are also some of those Shiny apps available here for you to do extended. You can actually create your own URLs if you want to access data and metadata through the web API. And also three Shiny apps that let you retrieve more data and metadata than you could through the vendor's environmental data portal. So there's a few extra tools here. If you get a chance, definitely take a look at those. We do have an internal and an external system. And what you'll see on the external system is daily data. That's the best resolution or the highest resolution you'll see. But there is a way, again, using through the web API where you can actually get to sub-daily data. And we are available at any time for questions and guidance. So feel free, while this opens up, the contact us button over here, feel free to send us an email if you ever have a question. Likewise, we do have a document here with user instructions on navigating the system. It goes into pretty good detail. And if you want to pop back to that page I just launched from and go to those advanced search options, and this button will take you back to that launch page. This is what you'll see when you first get in. The station overview tab will be highlighted, and you have a map interface. We had one in our old system, but then, as Granville mentioned, technology changes over time. We lost our map, and actually that was kind of a great loss because that's the way a lot of people want to search for what they're looking for. There are different layers available here. These are actually layers, the drainage basins, county, and water management districts. These are integrated from our GIS system. And then you have some options for changing some of the base layers. And these came with the software. These were configured with the software. And then let's see, it's just going to probably hesitate a little bit. Okay, and so then you can also label your stations, which is really only useful if you're zoomed in, but you can turn this stack here, these overlay menus on and off. Okay, and then you just have a little legend down here, shows you what each of these symbols mean, and your usual pan and zoom, your usual zoom in, zoom out, and just, click and drag, you can pan around. The usual map controls that I think everyone at at this point is familiar with. We offer filters on the left side if you're not really sure what you're looking for. Maybe you want to find groundwater, surface water, atmospheric. These are our three major resource types, and this is how we had our data organized previously, and we've kept to that same standard. And so you can narrow down your selection and say, well, I'm really only interested in atmospheric, ET, and rainfall stations, and that automatically will show you the results here on your screen. There's a station type, which is a secondary underneath the resource type. It's dependent on what you've selected in this choice, and so you'll only see rainfall and weather stations here. If you were to clear your filter, and each time you do a selection, you will see the number of stations out of the total number. If you clear your filter, now your station types are all different kinds. So if you know exactly what you want, you can go right to the station type menu. I should point out this is not the total number of stations that we monitor on an ongoing basis. This is how many we've had in the system historically. They may have data, they may not have data, they may be planned for future data collection, they may have been discontinued, but this was huge for our vendor. I don't think they'd ever seen anything of this scale. So we had to make a few accommodations, but I think it worked out pretty well. We also categorize our stations by their current data collection status. Some of these unknown ones may be from other agencies. Some are planned for future data collection, and we have quite a lot of active ones. So these are stations that we're either collecting monthly or on an ongoing basis, where we're getting levels, hydrologic or water quality data. For our groundwater folks, we also offer them the option to select by hydrostratigraphy. And then for water quality, they have their measuring program codes out here if people are looking for stations within a particular measuring program. Likewise, you can also choose by parameter, what parameters collected at that station. So that's actually pretty cool. There's a lot of detail here. So I've drilled down now. I'm looking for active superficial aquifer with water level. And so this is what I get if I'm looking for that. And I'm going to clear this. Likewise, if you already know what you're looking for, let's say I want, let's go back here. Let's say I'm looking for a station associated with the Myakka River. It will zoom right to that area, and then you can click map again and zoom right in on it. Table, not surprisingly, shows you those stations that you just selected. You can adjust what you see, so it's a little bit easier in some cases there. So you can see more information about the stations. And if you double click on a station, either in the table or on the map, it will bring up another window with some metadata about the station, and it'll also show you if there are data for the station. Let's see if I can find one where I think we have some data. Oh, of course not. Let me go. Let me pick another one where I know we have data. Our stations are all organized in our database with a unique ID. And in this case, I happen to know that the station for this particular well is 889859. I could have entered in the name as well. And now we see that we have water level data available. And if we click the water quality tab, we'll see that we also have multiple parameters of water quality data available. If we click on some of these, you're limited to 5. So that's something that, you know, we had to overcome. And so Asmita has written these apps that let you retrieve more than 5 parameters at once, and for more than 5 stations. But the nice thing is you can graph everything in one picture. So you're not having to download all the data and do all of that yourself. So here I've graphed some water quality data. If I look at the table, I can download it, export it from here. You can also set your time ranges. There are a lot of different controls for setting your time range. And then I could also go back to the hydrology tab and maybe graph the water level. Again, you can set your time range to anything that you want using different controls. And you can download hydrologic data using this little icon over here. There won't be an export button in the middle of the screen like there is for water quality. So you have several options for downloading your data here. So we also provide some additional information for the station. Let me see if I can find it here. You could also click on it on the map and bring up that information as well. So again, water quality, multiple parameters will bring them over here where you can actually select them. If you click them over here, you're only going to see one at a time. That was another interesting thing for us. Water quality, discrete water quality and continuous time series or hydrologic data were handled a little bit differently. So when we were having this portal configured, we really had to think about, you know, what's the best way to do this and how are we going to communicate this to the user so that it's not confusing. You can also graph multiple stations with different parameters on the same graph, which we found really helpful. So let's say I was looking at these two stations over here. You can turn their labels on once you've zoomed in. And you can then look at what data are available for them. Let's see, I'm going to turn this back on so I'm sure that I'm checking the right kind of station. And it'll show you if there's currently instrumentation on it. All of these were things that we decided we wanted on this portal, so we had to let the vendor know what we wanted. So I've selected two different stations. I want precipitation and 88 water level. So these are different stations, different parameters, but we were able to bring it up on the same graph. And that was something that we had always wanted to have that we didn't have before. So there were improvements, definitely, to WMIS. But as admit to say, you don't get everything. There's going to be some trade-offs. You're going to get really good, maybe newer, more modern tools. I mean, everybody's used to using web-enabled tools right now. But you may lose a few things too. You may lose some functionality if something was written specifically for your organization with your earlier system. This was the advanced. I just clicked that advanced search tab. That's how I went to the EDP to begin with. And again, these are just awesome apps that were written in-house, and would encourage anybody, if you're looking at the portal, go ahead and look at these afterwards, because it'll really show you how you can extend the power of the portal. But it just goes to show that it really helps to have a committed team with, you know, a team of problem solvers, really, people that like these challenges and want to find ways to improve on what you have. So I think really we're very happy with the outcome with the final product. But we continue to change it and to improve it. Definitely helps if you can make these changes yourself. You don't want to go to the, you know, you don't want to go to the contractor every time and say, I need you to, you know, change the configuration for this and this and this. You need to have a team of people who are committed to it and want to make these improvements and are going to take the time to learn how to do that. But I would just encourage people to go in here. You can't break anything. Check out the user instructions, and you can download it, you know, or print it out and go through it and see if you can get what you need. Try out the apps, and if you do have any questions, just click this button here and we will be happy to walk you through anything. So thank you.
That's super helpful. Thank you, Margaret. I feel, I don't know, much better equipped to start looking around there and getting data where we might need it. So thanks. Any final questions before we drop off? Thank you so much, Catherine, and your whole team. I've really appreciated just all the clarity around particular lessons learned in implementing this. I found that to be really helpful. So thanks so much for putting this together, and we'll post the recording of this presentation probably tomorrow, or if not early next week. So thanks everyone, and have a great afternoon.
Bye.
Thank you.